polarity, to associate polarity of molecules with their shape. In polar molecules, there is a net unequal sharing of electrons. So if we have unequal sharing, net equal unequal sharing of electrons, we called polar. If two dipoles are at angle, they will not cancel it out. In a nonpolar molecules, there is a net equal sharing of electron, okay? And also, if two dipoles are in opposite directions, they will cancel each other. This can be determined looking for electronegativity and shapes. So what is electronegativity? Electronegativity is the ability of an atom to attract electrons in the chemical bond. Polar bond results when highly electronegative atom bonds to a less electronegative atoms. A covalent bond is polar if there is a significant differences between the electronegativities of the two atoms. Look at this table. So if the electronegativity differences, it's between 0 and 0.3, the molecule is nonpolar. If it's between 0.4 to 1.9, it's polar. 2 or greater, it's ionic bond. For example, we have carbon and fluorine. The electronegativity of carbon, it's 2.5. The electronegativity of fluorine, it's 4. And we see because fluorine high electronegative than carbon, so it will take the partial negative, and the carbon, because it's less, take a partial positive, and we call it a dipole. Look at this example. It's a hydrogen molecule, because here between each atoms it's equal sharing with oppositely charged, so it's not nonpolar. But for hydrogen chloride, chlorine is high electronegative and the hydrogen is less electronegative, so we see the net dipole in this direction, and the molecule is polar. Here as well we have hydrogen fluoride, fluorine high electronegative than hydrogen, so the molecule is polar. If one end of a molecule is slightly positive and another is slightly negative, and the molecule is the molecules polar. Polarity depends on the shape of the molecule. For example, we have CO2 and H2O. CO2 is nonpolar because the dipole cancel each others out. So here we have a carbon, this is oxygen, this is the oxygen. Oxygen is high electronegative than carbon, so the row direction will be for oxygen, and this is for another oxygen, because so it's oppositely direction, it will cancel each other, so this molecule is non-polar. But for hydrogen and oxygen in H2O, it's polar because the shape is bent, not linear like that, and the oxygen is high electronegative than hydrogen, so the net dipole it will be with the oxygen direction, and the molecule is polar. To determine polarity, we need to the following. First of all, we should draw Lewis structure. Second, we write the formula like ABE notation or AXE notation. This point, if surrounding atoms are identical in the following shape, the molecules has no dipole, so it's not polar. If we have identical atoms for linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, octahedral, or square planar, so the molecule is non-polar. Right now, we have examples. It's also from AP textbook at page 382. Sorry. Let's start with first one. It's CH2O. The notation is AX3 and the molecule shape is trigonal planar. It's O double bond C, H and H. Don't forget the electrons here. So between carbon it's slightly to carbon direction, and between carbon to oxygen it's highly differences electronegative, so the oxygen pull the electrons, mu not equal 0. The mu is the net dipole, so this molecule is polar. For NH3 it's AX3E and the shape is trigonal pyramidal. It's N with hydrogen, also here hydrogen, and we have lone pair. The differences between hydrogen and nitrogen, so net dipole not equal 0 as well, and it's with a nitrogen direction, so also ammonia is polar. The last one, we have AX5 and the shape is trigonal bipyramidal. It will be like that, Cl, Cl. And the electronegative differences between phosphorus and chlorine. Chlorine is high electronegative, so they will cancel each other. Mu not equal, it's equal 0, sorry. So it's not polar, or it's non-polar. Also here we said if the all surrounding with central atom are identical in trigonal bipyramidal, it's non-polar. Here trigonal pyramidal, it's also identical, but don't forget the lone pair of electrons. This will make a high electronegativity for hydrogen, so it will make it polar. And for these molecules we have not or non-identical atoms. We have hydrogen and also oxygen, so the molecule is polar. Thank you so much.